NASA has taken another giant leap toward unraveling the universe's deepest mysteries. In a historic milestone, the James Webb Space Telescope has successfully completed its final deployment sequence. What followed was a revelation unlike anything seen before, an image that has electrified the scientific world and captured the imagination of people everywhere. For the first time in human history, Webb has delivered the clearest, most detailed image of Proxima b, the closest known exoplanet beyond our solar system. Often described as the crown jewel of modern space science, Webb's achievement is more than just a triumph of engineering. It's a turning point in our exploration of other worlds. Unlike the distant dots or faint infrared signals astronomers have relied on for decades, this new observation reveals Proxima b as a textured, tangible world. Using its cutting-edge near-infrared camera, NIR-CAM, and mid-infrared instrument, MIRI, Webb pierced through cosmic dust and interference, capturing planetary details with astonishing precision. Subtle variations in surface brightness, atmospheric layering, and even polar regions could be distinguished. Though not as detailed as images of Earth or Mars, this view transforms Proxima b from an abstract concept into a physical place. For years, planets outside our solar system were known only through indirect methods. Detecting a star's wobble caused by gravitational pull, or measuring slight dips in starlight as planets passed in front. These techniques confirmed the existence of worlds but offered little insight into their true nature. Webb changes this. By isolating planetary light from the overwhelming glare of stars, it provides direct observations, unlocking a level of detail once thought impossible. Proxima b orbits within the habitable zone of Proxima Centauri, a red dwarf star just 4.24 light-years away. At about 1.3 times Earth's mass, it is a rocky planet and has long intrigued scientists as a potential Earth-like neighbor. Yet, until now, its proximity to a volatile red dwarf star made it nearly invisible to older instruments. Webb's coronagraphs and precision filters finally succeeded in suppressing the star's light, isolating the planet itself. The data revealed promising clues: atmospheric absorption patterns pointing to carbon dioxide, traces of water vapor, and possible hints of methane. While none of these confirm life, they are consistent with conditions where life could exist. Temperature readings show moderate surface values, within ranges compatible with liquid water. The image itself tells a story. Bright regions may suggest ice caps or arid expanses, while darker areas could represent oceans or dense cloud cover. The faint reddish tint reflects the influence of its red dwarf sun, giving Proxima b an otherworldly yet strangely familiar appearance. This is more than a technical feat, it's a philosophical moment. Humanity has long asked, are we alone? Microbial life thrives in extreme conditions on Earth, from boiling vents to frozen deserts. If worlds like Proxima b share Earth-like traits, it strengthens the case that life may be widespread across the galaxy. The breakthrough is even more significant because red dwarfs, like Proxima Centauri, make up roughly 70% of stars in our galaxy. If Webb can reveal this much detail for Proxima b, the number of potentially habitable planets we can study expands dramatically. Future targets such as the TRAPPIST-1 system or LHS 1140b may soon yield equally rich insights. Behind this achievement is a collaboration of disciplines: astrophysicists, engineers, chemists, and data scientists working in unison. Webb's success is not just about optics, it's also about advanced computing. Machine learning algorithms reconstructed faint planetary light from noisy data, turning raw observations into the breathtaking image now before us. For the public, the impact is profound. Seeing a distant world with such clarity collapses the vastness of space into something more intimate and relatable. It transforms exoplanets from abstract science into places we can almost imagine standing upon. Technically, the challenge of imaging Proxima b was monumental. The James Webb Space Telescope had to maintain flawless precision in every aspect of its design. Its segmented golden mirrors, spread out across the size of a tennis court, had to remain aligned down to a fraction of the width of a human hair. Any misalignment would blur the faint light of the exoplanet into the overwhelming glare of its parent star. Thermal stability was equally critical. Webb orbits nearly 1 million miles from Earth, shielded from the Sun by its massive sunshield. Even the slightest thermal fluctuation could warp its optics or distort the delicate sensors tasked with separating planetary light from background noise. Add to this the need for adaptive optics, correcting distortions caused by cosmic interference, and it becomes clear just how extraordinary this achievement truly is. Then came the unique challenges of Proxima Centauri itself. As a red dwarf, it is highly active, frequently releasing solar flares that can outshine the planet and flood detectors with interference. On top of that, Proxima b completes an orbit in just 11 Earth days, meaning Webb had to carefully track its rapid motion across the star's glare. To capture a clean image, the telescope required weeks of repeated observations, all stitched together to reduce noise and confirm accuracy. That the final result emerged with such clarity is nothing short of remarkable. Now, with this new image in hand, scientists are moving beyond the challenge of detection into the realm of detailed study. Teams are constructing sophisticated three-dimensional climate models of Proxima b, simulating how its atmosphere might circulate under the dim, reddish light of a red dwarf. These models explore how heat might redistribute between the planet's day side and night side, how its rotation could influence weather patterns, and how atmospheric currents might stabilize or destabilize the climate. Another crucial question is whether Proxima b generates a magnetic field. On Earth, our magnetic field protects us from harmful solar radiation and preserves our atmosphere from being stripped away by solar wind. If Proxima b possesses a similar shield, it could mean its atmosphere is far more resilient than previously thought, making it a stronger candidate for long-term habitability. The implications extend far beyond one planet. Webb's success has emboldened discussions about humanity's next great leap, interstellar exploration. Concepts that once seemed like speculative science fiction are now being examined with renewed seriousness. The Breakthrough Starshot initiative, for example, envisions launching fleets of tiny, laser-propelled spacecraft that could reach Proxima Centauri within a single human lifetime. With Webb's image as a guide, scientists now have a clearer target, real measurements of atmosphere, surface conditions, and orbital behavior that can shape the design of such missions. For the first time, humanity does not just know of an exoplanet through numbers on a chart. We can see it, study it, and imagine what it might be like. The leap from speculation to observation is profound. A century ago, even planets within our own solar system were blurred mysteries. Now, we are mapping worlds orbiting other stars. Webb's first direct image of Proxima b is more than a scientific achievement. It is a cultural and philosophical milestone. It invites us to think of distant worlds not as abstract data points, but as real places, potential neighbors in the vastness of space. This is the dawn of a new era of exploration, one where humanity begins to extend its gaze outward not just to wonder but to prepare. The universe is no longer an unreachable frontier. With Webb's vision, it becomes a map waiting to be charted, one world at a time.